So let's look at this equation, x squared equals 9. So x squared equals 9 is a quadratic equation. And to solve quadratic equations, we typically set them equal to 0. So I would subtract 9 on both sides. And now I want to see if I can factor. Is there a GCF? No. How many terms? 2. Perfect squares are perfect cubes. This is perfect squares, so I'm going to use dots. So this becomes x plus 3, x minus 3, and then I tee off from there. I get x equals 3, x equals negative 3, which makes sense because I should have 2 solutions since my degree is 2. That means I have 2 total solutions. So there's an additional way or a different way that you could solve this question as well. I have x squared equals 9. So I could undo this squared using opposite operations by square rooting. So I get x equals the square root of 9, so x equals 3. But the problem is I now only have one solution. So whenever you square root something, you must always take the plus and the minus. So that's where I get my second solution from. This is called extracting the square. And we can apply this method when there is a binomial squared as well. So remember that a binomial means 2 terms. So I have x plus 3 squared equals 25 right below as my next example. So if I wanted to do this, I'll do it on the side. X plus 3 squared equals 25. If I wanted to solve this by setting it equal to 0 and factoring, I would first need to deal with this binomial squared. And a binomial squared, remember that I have to write it 2 times, and I have to apply the box method. And then I would need to combine like terms, set it equal to 0, factor, tee off, and solve. So there'd be a lot of steps to do here. But I can apply a similar procedure to extracting the square. I can undo this squared by square rooting it. So I'm going to square root this side, and I'm going to get x plus 3. But whatever I do to one side on an equation, I have to do to the other. So I'm going to square root this side as well. So it's equal to plus and minus the square root of 25. In this case, the square root of 25 can be square rooted. It is a perfect square. So I get x plus 3 equals plus and minus 5. I want the x by itself, so I'm going to subtract 3 on both sides. So I get x equals negative 3 plus and minus 5. Now this is 2 separate solutions, remember. Negative 3 plus 5, which gives me 2, and negative 3 minus 5, which gives me negative 8. So my solutions are negative 8 and 2. So now what happens when I take a look at an example like this, where it is not already squared? This is going to be called completing the square. We are going to force it to be squared. So we are always going to do the same thing. I am always going to put it in standard form, which means it needs to be set equal to 0, highest exponent down to the lowest. So I'm going to add 18x on both sides. So I have x squared plus 18x plus 153 equals 0. Now remember that my goal is to get this as something squared, but I can't just jump right there. I have to do a little bit of work. So I'm going to set up my next step. X squared plus 18x plus blank plus 153 minus blank equals 0. Now, think about this for a second over here on the side. If I have x plus 3 minus 3, I really just have x. If I have 7 plus 5 minus 5, I really just have 7. When I have a plus and a minus, they are called additive inverses. They cancel each other out. So by me having a plus blank and a minus blank, I'm really not adding anything to the equation. I'm just manipulating it to work. So The way that we are going to get the number that goes here and here is b divided by 2 squared. And b, remember, is this term. So 18 divided by 2 squared is going to give me 9 squared, which is 81. And now what's in this parentheses here, the reason it's in parentheses is because I'm now going to use the AM method to factor. So it's really going to come out to x plus 9, x plus 9, but that's really x plus 9 squared. So that's always your goal. You want to get it into something squared, a binomial squared. Now these pieces are like terms, so if you need to, put them in your calculator. I have 153 minus 81, oops, and I get 72. So plus 72 equals 0. Now I can solve. So I am going to subtract 72 on both sides. So I get x plus 9 squared equals negative 72. I'm going to extract my square by square rooting both sides. So I get x plus 9 equals positive negative square root of negative 72. Remember that I'm going to, if I can square root it, I'm going to do that here if it's a perfect square. This one is not. I'm going to break this down. I have a negative and another one. If you need to, go to your calculator. 72 divided by x. I'm looking for the pairs. One of them has to be a perfect square. So take a minute if you need to. Do it in your calculator. This should be 36 and 2. So I have 6i radical 2. So I have x plus 9. I'll put this back in red. So I have x plus 9 equals plus and minus 6i radical 2. And then my last step is to get the x by itself. So I'm going to subtract 9 on both sides. So I get x equals negative 9 plus or minus 6i radical 2. And there's my solution. Now, this was a quadratic equation, so I could check it in my calculator. If I go all the way back up to my original, I can put it into my calculator in one of two ways. I can either go up here and put x squared plus 153 in y1 and negative 18x in y2, or I like to always go into the standard form. So I have x squared plus 18x plus 153. I'm going to hit zoom 6 like I always do. It doesn't graph anything for me. I can go to my table. I'm looking. I don't see any zeros. So that means it doesn't touch the x-axis. So I have imaginary solutions. So that means I should have i's in my answer. Let's take a look at one more together. X squared plus 3x plus 5 equals negative 10. So once again, I'm going to start by putting this into standard form. So I have x squared plus 3x plus 15 equals 0. I'm going to set up my two lines. So my first line is x squared plus 3x plus blank plus 15 minus blank equals 0. And my next one is my binomial squared, because that's my goal. So to get my blank space, it's b over 2 squared. So in this case, b is 3 over 2 squared. So it's your choice. You can leave this as a fraction or a decimal. If you leave it as a fraction, it might make it easier when it's time to square root things. So I'm going to leave this as a fraction right now. It's going to be 9 over 4. And remember, you don't need to be able to do that in your head. Write in your calculator in the home screen. Alpha y equals gets me my fraction, 3 over 2. gives me my 9/4. So plus 3 over 2. That b over 2 is always going to be that binomial squared part. And then I'm going to do these two pieces together. So in my calculator, 15 minus my 9/4, and I get 51/4. So plus 51/4 equals 0. And now I'm going to continue solving. I'm going to subtract 51/4 on both sides. So I have x plus 3/2 squared equals negative 51/4. I'm going to square root both sides. So I get x plus 3/2 equals positive and negative the square root of negative 51/4. So let's work with this radical a little bit here. First thing is I'm going to take my negative, bring it to the front as an I. So I have plus and minus I radical 51/4. Then when you have a radical, first of all, this is not a perfect square. So now I'm going to try to simplify it. When I have a radical that's a fraction, I can break it into radical 51 over radical 4, because now this is a perfect square. So that means I have plus and minus I radical 51/2. And then I still have this part here, so I have x plus 3/2 equals this. I'm going to subtract my 3/2 on both sides. So I get x equals negative 3/2 plus and minus radical 51/2i. I just put my I at the end because I always want it in a plus bi form. So that's why I just stuck the I at the end. So that's how you complete the square to solve a quadratic equation.